Welcome back. As you know, I am Eli, the computer guy, here for your daily dose of the roars as I scream about the very stupid stuff going on in the world of technology. Do remember I do these videos in order to fund silicondojo.com, free hands-on technology education in Durham, North Carolina. If you're interested in coming to one of our classes, we have a class coming up on AI computer vision using something called Moondream next week. We have another class coming up on pushing AI to the edge. Will be coming up in the beginning of January. Take a look at silicondojo.com to see what our schedule is. And if you want to support free hands-on technology education, there's a donor box link down below. And with that, let's get into the story of RISC-V, because I think the story of RISC-V is an interesting thing to take a look at and see how politics actually pushes our profession in different directions, right? So when we talk about RISC-V, basically this is a processor architecture, right? So you have the x86 processors from Intel, you have the ARM processors from ARM, you have other processors out there, but basically with RISC-V, this is an open source hardware standard. Kind of think like Arduino, but hyperscale it, essentially. Imagine from a hardware standpoint, if the entire architecture was completely open source and anybody who had the ability to be able to manufacture these kind of chips was able to manufacture those types of chips and be able to modify them as they see fit, right? If you look at the x86 standard from Intel, basically this is a completely proprietary standard. More or less, only Intel and AMD make these particular types of chips. Intel essentially owns all of that. If you look at ARM, if you look at ARM, basically with their chips, what they do is they design the architecture. They come out with a design architecture, and then companies license that design architecture. So Apple licenses the ARM architecture so that they can make their M1 chips, right? Google licenses the architecture so they can make their chips and the whole nine yards. And so RISC-V comes into this environment. And one of the things I've talked about for a long time is that RISC-V was fine. I wasn't particularly snarky at RISC-V as a concept, but also it's kind of like one of those, who the hell cares? Right? It's important to understand the technology world. You've only got so much time. You've only got so much energy. Like a lot of times, if you have a product that works good enough, then by God, you got a product that works good enough. You don't got to worry about these other things. Hey, why don't we buy RISC-V? Because our servers are fine. Intel is doing a fine job. I don't have to worry about it anymore, right? Ubuntu, right? Even if you look at silicondojo.com, a lot of things we do, we standardize on Linux using Ubuntu. Why do we use Ubuntu? Because it's fine. Again, it's legacy. It's fine. I learned Ubuntu, 15 years ago at this point in time. It's a Debian distro. It's fine. There's no reason to go anywhere else. One of the things I think about though is like with Windows. I used to be a Windows fanboy. When I did videos for YouTube, I used to be a vociferous Windows fanboy. I used to just hammer the shit out of Macs, right? But then the issue came up, right? And so I had my MCS ENT 4.0. I had gone through the boot camp for 2000. I had supported Windows products for 12 or 13 years at that point in time. I was die-hard Windows. I die-hard Microsoft, right? ActiveSync made the nip so hard. I loved ActiveSync, right? You just don't know. You just don't remember those days. ActiveSync was an important thing. But anyways, but then what happened? Right? Steve Ballmer came out, and Steve Ballmer said he didn't care what customers wanted. They would deal with Windows 8. And so I dealt with Windows 8, and I hated Windows 8, and I went to Mac OS, and I went to Mac, and I haven't been back, because fuck it. Fuck it. Once you leave Windows, you don't want to go back to Windows, right? And so I think that's the interesting thing when you look at RISC-V. Like, it's an open source standard, nothing to be snarky there. Their performance is whatever the fuck it is, right? There's nothing to be snarky with that. It's an open source standard with only so much investment. So you're only going to get the performance you're going to get. And so that's where it's like, it's like, look, you got the x86, you got the ARM processors. Are they perfect? Absolutely not, but they're good enough. The interesting thing, we talk about politics, right? We talk about the idiocy of the Trump administration, the idiocy of the Biden administration, the idiocy of the Obama administration, right? Basically making China the enemy. Well, here's the thing. Think about if you're Chinaman. You're Chinaman. All you want to do is build servers. All you want to do is build and ship stuff, right? But now, what if you might not be able to get access to hardware What if you might not be able to get access to what you need simply because a senile, batshit crazy, old, racist white guy half a world away has decided your civilization has progressed far enough? How would you feel about that? How would you feel about it? And so one of the interesting things in the Chinese tech stack world is that they are embracing open source. At the exact same time, the Western world is embracing more and more of proprietary. And so the curious thing is RISC-V fits into their worldview a hell of a lot better than either ARM or x86 does at this point in time. And so it looks like with the disastrous foreign policy of the United States, it's driving China to focus more on RISC-V, which then is making RISC-V better and better. And it's actually interesting. They're looking at it for more and more AI deployments. So if you had asked me a year or two ago whether I thought RISC-V was going to be used for AI, I'd be like, I don't know, maybe the hardware controllers? Like it's somewhere. It's in the neighborhood of AI. I would not have thought of it actually being a core processor for some of these technologies, but that's how it goes. And that's one of the reasons I talk about politics in these shows, because, again, like it or not, in 2025, politics is driving our industry to a surprising degree. So anyways, RISC-V exceeding expectations in AI China deployment. Though to be clear, let's just be clear here, exceeding expectations might be it works. Oh my God, did you see? The processor turned on. That exceeded my expectations. That's one of the things you have to be careful about with words, flowery words, when you talk about technical things, is they don't actually mean anything. Believe me, I have had products far exceed my expectations and go directly in the trash can. Wow, I didn't even think that product was going to turn on. By God, it did turn on, and it's going to the trash. So anyways. RISC-V, the number 2, I don't know what they're talking about this. RISC-V, the number 2 processor architecture behind ARM, is growing beyond expectations in AI designs and China deployments. These were among the key trend lines at the RISC-V Summit held on 22nd and 23rd of October in Santa Clara, California. RVA 23, ratified in October 2024, was also in the spotlight, being a massive investment in bolstering the RISC-V ecosystem. It pulls together software, tools, and features to help RISC-V architectures evolve in a free and open space. At the summit, RISC-V thought leaders telegraphed their intentions regarding ecosystem development, while community digests RVA 23. The next major ecosystem release is clearly years away. So anyways, one of the curious things about this too is everybody is trying to create their own wafers now. So it's not just that the United States is trying to bring chip manufacturing back to the United States, but China's having all kinds of problems because of us. Thank you. We're making a disaster for China. So China's trying to figure out how to create chips. Not only that, Japan is trying to renationalize chip production. Europe is trying to re-continent-wise? I don't know. They're trying to bring more chip production back to Europe. And one of the interesting things is you start looking at countries like Brazil. Again, we talk about things like BRICS, Brazil, India, South Africa, that type of thing. One of the things for them to consider, is can they create a national chip industry? If they're doing ARM, no, probably not. If they're doing x86, absolutely not. But look, if RISC-V becomes more normalized, there becomes more support, it might actually become a thing where Brazil is using Brazilian chips and South Africa is using South African chips. And one of the things to consider there is what happens to our industry, what happens to our profession when we refracturize? Right, there's something called the convergence, not that other thing. Anyways, there's something called convergence. So the technology stacks, back when I got involved in technology, right, telephone systems use their own tech stack, surveillance systems use their own tech stack, access control systems use their own tech stacks, computer systems obviously use their own tech stacks. They use different types of wiring, they use different communication protocols, everything was different. Then we had something called convergence. So you go back to about 2005 timeframe, and the idea was, hey, what if we run all of this on IPv4, essentially with x86 systems. So instead of having a telephone system, you now have a VoIP server. Instead of having an access control system, you have an access control server. Instead of having cameras, you have an NVR, network video recorder, that type of thing. And basically that can solid everything. It makes life a lot easier when everything's running on TCP/IP, when everything's basically using Linux operating systems, when everything's using basically the same stuff. It makes it easier to administer and to build out and that type of deal. What becomes interesting is in this world, what happens when it's not simply bifurcating? Like it's very easy to see with what's going on that it's the West versus China. It's quote unquote the West versus quote unquote China. But with things like RISC-V, if this becomes more viable, it's not simply the West versus China. It's Europe has a standard, US has a standard, Brazil has a standard, Russia has a standard, South Africa has a standard. And what does that look like? But the traction in China and AI mindshare created the wow factor of the event. Richard Warbaba, principal analyst for ASIC, SoC, and IP at the SHD Group, explained how the market research firm he represents had to revise his RISC-V projections after receiving data from China. He told EE Times that the rise in China was mainly due to automotive, the industry seeking low-cost solutions and looking to aggregate to fewer parts to reduce bottlenecks. Quote, the automotive is catching up 30 years of compute dearth and striving to make it up in 5, said Andre Gallo, CEO of RISC-V International. So far, we have been doing automotive in a rigid way. So one of the big things talking about here is, again, if you're looking for, I want some kind of ubiquitous compute device that's going to be relatively inexpensive and I don't need it to run like the latest fucking video game, RISC-V makes sense. So one of the things they're talking about here, especially in China, is the automotive industry, right? You need a lot of little compute. You need a lot of little compute to do a lot of different stupid stuff. That's a great place for RISC-V to be put in. Though automotive and consumer markets boast the highest penetration of RISC-V designs, blah said that the instruction set architecture is tailor-made for AI. He added that RISC-V is fortunate that AI is happening now. Quote, AI chip designers are having a look at both ARM and RISC-V processor architectures. Quote, the heterogeneous nature of AI chips favors RISC-V. Systems on a chip can support both RISC-V and other ISAs, allowing AI applications to pick the best core for each function. RISC-V's ability to customize implementations helps chip designers right-size CPU cores. Moreover, the ability to add extensions to RISC-V enables new developments in the fast-moving AI applications. So basically the idea here is build exactly the chip that you need for whatever solution it is that you're trying to deploy. Case in point, NVIDIA recently acknowledged that it's using RISC-V in all its parts. There are 10 to 40 RISC-V cores in NVIDIA chips. The AI powerhouse has also announced plans to support CUDA to RISC-V processors. That validates the importance of RISC-V and negates objections regarding RISC-V adoptions. The person acknowledges that RISC-V has gained more momentum in edge AI designs than data centers. He also pointed out that in consumer space, edge AI applications are more prominent. In fact, during his opening speech at the RISC-V Summit, Gallo mentioned the recent launch of Synaptics Astra Edge AI processor, which incorporated Google's Coral NPU based on RISC-V architectures. See the idea here? They're saying with AI that RISC-V works better at the edge than it does in the data center. Hey, remember when ARM worked better on, the very, very cheap smartphones and didn't work very well in the computers? Right? That wasn't that long ago. So it could be the inroads for AI. Quote, the cloud may have fueled the AI revolution, but the edge is where AI truly touches the real world. Let's see here. Next, she explained the RISC-V enablers, like an open ISA tuned for real-time systems and custom extensions for control and perception. Also talked about domain-specific accelerators and how they boost reliability and predictability in edge AI devices. Quote, RISC-V and edge AI are heading in the same direction. So anyways, I thought that was kind of an interesting story from the EE Times talking about RISC-V and how it looks like China is basically leading the way on a RISC-V, which makes a lot of sense in the current geopolitical environment. And so the curious thing is, right, as they lead in RISC-V, where will those additional developments, bleed out to? It'll be fascinating to see. If you had asked me a couple of years ago about RISC-V, as I will say, RISC-V was cute. Nothing against RISC-V. Also had zero plans to use RISC-V. it looks like in the next number of years, whether or not I have plans to use RISC-V, RISC-V might be being used in the architectures that I'm connecting to. So what do you think about this? What do you think about RISC-V? What do you think about the Chinese paradigm of technology, of open source, right? Nobody really owns the idea. The entire point is to ship as fast as possible versus, the quote-unquote Western way of doing things is this proprietary. People are allowed to have a monopoly over an idea, and that's where the real value comes from. What do you think happens when this whole open source initiative really hits the hardware world, especially at this inflection point in time where globalization is dying, right? Where the idea of Brazil or Argentina or Kenya having wafer manufacturing capacity actually does start to make some reasonable sense. I don't know. Put your thoughts down below. Do you remember I do these videos in order to support silicondojo.com, free hands-on technology education in Durham, North Carolina. We have a class coming up on computer vision using something called the Moon Dream AI model. That'll be up next week. We have another class coming up on pushing AI to the edge with Raspberry Pis in another few weeks. If you're interested, take a look at our schedule at silicondojo.com. If you want to support free tech education, there's a donor box link down below. And with that, see y'all later.